In this lesson I'm going to go over how you can describe the distance formula and then how you can describe the midpoint formula. So first of all, I have a segment here, segment AB. The coordinates of A, 1, 4. The coordinates of B, 5, 9. I want you to think about how you can use knowledge that you have had in the past to find the length of this segment. Okay, you may have done it several different ways. I'm going to show you one way using the Pythagorean Theorem. Pythagorean Theorem is actually used for right triangles, and the formula for that is a squared plus b squared equals c squared, where a and b are both lengths of legs of the right triangle, and c is the hypotenuse. Well, if you look at this, you can actually construct, well, draw anyway, a right triangle by taking from one endpoint going horizontal and from the other endpoint going vertical. Now I could have also used the horizontal up here and the vertical up here. And if you think about it, to go from 1 to 5 along the x, there's a length of 4 units. Also, to go from down here, which would be 4 on the y, up to 9 on the y, that would be 5 units. And then this would be thought of as your hypotenuse, with this being the right angle. So, if I let A be 4, that means I would want B to be 5. So you have 4 squared and 5 squared equals c squared. 4 squared is 16. 5 squared is 25 equals c squared. And then if you add 16 and 25, you get 41. So 41 equals c squared. Then you would take the square root of both sides, and technically you should put a plus or minus here in a theoretical problem, but because this is a length, this has to be non-negative, so I can just leave that positive. But the square root of c squared is c, and I get the square root of 41. Now, when you put that in the calculator and you get an answer, then you get what's called an approximation. And for now, in our problems, I will be asking for approximations when you get an answer like this. Later on, we'll learn how to actually simplify this if possible. This is not possible, but this would be considered an exact answer. Okay? Anytime you have to round, it would have to be an approximation. But that is a way you can actually find the length of this. With the square root of 41, since the square root of 36 is 6, the square root of 49 is 7, this would be between 6 and 7 units. Now, we can generalize this. And when we generalize in mathematics, we change the values that you would need to solve the problem into variables. And since we normally let the first coordinate be x, the second coordinate be y, I'm letting this be x1, y1, and this be x2, y2. Now I made this one exactly the same as this one, but I don't have to. In fact, to make things a little bit easier, I'm just going to pick a point here. I'm going to pick a point here. And I'm going to draw it. And we'll call this x1, y1. I'm using the 1 just to distinguish it to be different from this one. It has no arithmetic value. It is just called a subscript. It is used for identification purposes. So we know that this x is different than this x. Okay? Even if the values ended up being the same in my situation, they could be different. So I have to assume that they are different. Well, if I take this strategy here, and make a horizontal and then a vertical. So this is a right angle. So you're still thinking of this as the hypotenuse, what you're trying to find. One key to solving this is figuring out a way to represent these two lengths. So think about how you could use that in terms of x's and or y's. Well, if you look up here, you've actually taken 5 minus 1 to equal 4. Now I'm letting this be x2 and this be x1. So what I could really do is represent this length as x2 minus x1. Here I did the same thing, but I did it with the y's. 9 minus 4 equals 5. So in this case, it would be y2 minus y1. So I have something to represent both lengths. That would always be true. So if I think about the Pythagorean theorem, then I have a squared plus b squared equaling my answer. Now how I represent that varies. I know a little bit about the formula, and sometimes they use a d for that. So we're going to actually change this to a d for this situation. Well, these are my legs. One of them is x2 minus x1. Now notice I put that in parentheses because this whole thing is squared, so when I substitute this in its place, it's this whole thing squared. So you will actually subtract first, then square it. Plus, from the same reasoning, this becomes y2 minus y1. That quantity squared. And we still have it equaling d squared. Now, up here, notice what we did. Once we had this, we put it together and we took the square root. We cannot put these two together because they're unlike terms. But what we can do is we can go ahead and take the square root. Now on this left-hand side, you're not going to be able to simplify this. But this will turn into d. So what you have is, if you switch things around, d equals this whole big thing, the square root, subtract your x's, quantity squared, plus subtract your y's, quantity squared. This is the distance formula. It's a little long, but if you know the Pythagorean theorem and how it works, and then remember you're subtracting your x's and subtracting your y's, all the distance formula becomes is an extension of the Pythagorean theorem on the coordinate plane. Okay, now we're going to talk about that same segment, but we're going to talk about the midpoint. Remember, the midpoint would be the place where it would bisect this. So we're going to look for the coordinates of the midpoint. Think about how you would do that. Okay. The nice thing about this is, if you sort of estimate where you think it's located, then really all you have to do is find the midpoint of the horizontal for your x and the midpoint for the vertical for your y. And the halfway point between 1 and 5, if you think about it, is 3. Because there would be 2 to the left of 3 and 2 to the right of 3. Also, from 4 to 9, if you think about it, you would actually have to go 5, 6. So there's 2.5 this way. This goes 7, 8, 9. So this would be 6.5 or 6.5, because you'd have 2.5. This having a length of 4, there's 2 on each side. This having a length of 5, it'd be 2.5 on each side. Now think about another way you could take 1 and 5 and get 3, and that same method would work to get 4 and 9. Use those two and get 6.5. Another way to look at the halfway point is to actually take the average of them. And if you take 1 plus 5 and divide that by 2, that's how you take the average of two numbers, you'd get 6 divided by 2, and that would be 3. So the x-coordinate would be 3. Do the same thing over here. 4 plus 9 and divide that by 2. So you get 13. 13 divided by 2, 6.5 or 6.5, or you could say 13 halves. They're all three exact values there. So I'm okay with any of those. Now, if you think about it, all you have to do to come up with the formula is to generalize this. It's almost like you have a formula here. So think about how you would write the formula for this. Well, if you just substitute in, your 1 was x1, so x1. This was x2, so x2, and then divide by 2. For your y's, the 4 is now y1. The 9 is y2. Divide that by 2. And you've generalized it, and this is considered the midpoint formula.